Hi class, today we are going to be talking about the metric system and about how we do conversions using the metric system. This big conglomeration of units and symbols that you see ahead in front of you on this slide, don't worry, you don't have to know all of this stuff. It's just a representation of some of the units in the metric system. Things that you should be aware of. The SI, we call that System International, also the metric system, unit for mass is the kilogram. Okay, the base unit for mass is the kilogram. The base unit for length is the meter. In chemistry, this is really important. The base unit for the amount of a substance is the mole. And we'll talk about moles a lot as we move on. The base unit for time is the second. And then some things you probably used in physics, electric current, luminous intensity. We will talk about temperature. In temperature, the unit we use is the Kelvin. Okay? So these are the important units we're going to be using in chemistry. Then there are also some derived units. Okay, derived units are a combination of base units. So volume, for example, you know the formula for the volume of a cube: width times height times length. If each of those units is in meters, we have meters times meters times meters. So volume in the metric system is meters cubed. Area, if we just have length times height, is meters squared. And then something that isn't on this chart that we will use, that's a derived unit, and you should get this down. We'll talk about this. We'll have a whole presentation on this in a couple of days. But density is mass per unit volume. Okay, so in the SI system, if mass is kilograms and volume is meters cubed, the units for density would be kilograms per meters cubed. Okay. We will also talk about volume using, instead of meters cubed, using liters for volume. Okay, and we'll talk about that when we get to our discussion on density. But these are the things you should know, the base units of the important measurements we're going to take in chemistry, and then just keep in mind we'll talk about density later. Okay, when we take measurements, there are two parts to that measurement. There is the number, which is very important, but the number alone means very little. We need a unit. And what you're going to find as we get into the calculations of chemistry, every time you write down a number when you're solving a problem, you need to include a unit. Okay, there will always be points given for writing down the units. So for example, 20 grams. 20 is the number, grams is the unit. 6.63 times 10 to the negative 34th joule seconds. Okay, we've got a number and a unit. Okay, and we said this a minute ago, but just to get this down again, when a little bit more neatly, the fundamental metric system units, or SI units. Again, mass is the kilogram, abbreviated kg. Length is the meter, abbreviated m. Time is the second, abbreviated s. Temperature is Kelvin, abbreviated K. And then electric current, ampere. Amount of substance, we will use this one, is the mole. We abbreviated MOL. And then luminous intensity, the candela, CD. We really will not use these units this year in chemistry. So those other ones, though, you should be familiar with. The whole premise for the SI or metric system is that every every measurement has a base unit, and then we change the value of that base unit by adding prefixes that have a value. Okay, and the prefixes that you should know for this class. Kilo means 10 to the third, or 1,000 of something. So if I have a kilometer, it means that I have 1,000 meters. All right, deci is 10 to the negative 1, or 0.1. So if I have a decimeter, that means I have 0.1 meters. Centa is 0.01. So if I have 1 centimeter, it means I have 0.01 meters. Milli, 10 to the negative third, that's 0.001. Okay, so 1 millimeter is 1/1000th of a meter. That also means that there are 1,000 millimeters in 1 meter. And then a couple of others that we want you to know that we use relatively frequently. 10 to the negative 6th is micro, and we use this Greek symbol to represent it. And then nano is 10 to the negative 9th. And when we get into our energy unit, we will be talking about nanometers, because that's the wavelength of light. Okay, so you should be familiar with these units. All right, and this is kind of just a graphic to show how the main units from kilo to milli line up. There's always a base unit. That base unit can be grams, meters, liters, okay? And then if we add the prefix to that, it makes this much of a change, or it means we have this many of that base unit. All right, so conversions in the metric system are really a matter of moving the decimal point, okay? We're going to, although you've probably learned that you can make metric conversions by moving the decimal point, we're going to learn to set up a conversion, and I'm going to have you always do your conversions according to this process. So, for example, if I want to convert 18 liters to milliliters, the first thing I need to know is, what is my conversion factor? And what that means is it's an equality statement. How many liters equals how many milliliters? So if we look at our chart, 1 milliliter is 10 to the negative third liters. Okay, so we could do this way. 1 milliliter is 10 to the negative third liters. Another way to write that is 1 liter is equal to 1,000 milliliters. Okay, so now that we have our equality statement, this equals that, we're going to set up a problem, and we're always going to set these up in the same way. The number and unit that is given is what we're going to start out with. We're going to start out by writing down 18 liters. Then we're going to make this T chart that's a conversion chart. And this is always over 1. Okay? And then we need to put our conversion factor in here, one part on the top, one part on the bottom. It's like we're multiplying by 1. But we've got to put it in so our units cancel out. So since we have liters on the top, we need to put liters on the bottom. So we're going to put 1 liter on the bottom. Then the other part of our conversion factor, 1,000 milliliters, goes on the top. By doing this, our units cancel out and give us the units that we need to solve the problem. So 18 times 1,000, 18 liters is equal to 18,000 milliliters. So that would be the answer to this conversion. We're going to try several more of these. So you should be writing these down and practicing as we go, because this is one of the key concepts and key ideas that you're going to need to know as we go through chemistry. So let's try an example. Convert 400 milliliters to liters. The first thing we need is our equality statement. So 1 liter is equal to how many milliliters? Okay, 1 liter is equal to 1,000 milliliters. And here's a way that I like to remember this. Remember those units. We had kilo, hecta, deca, and then we had the unit, which would have been mass, grams, liters, or meters. So the unit, and then we had deci, centa, milli. Okay, so there's a way, there is a way to remember this. Remember the order of these units and how they go. And I'll just write this down here. It's a little mnemonic device. King Hector died upon drinking chocolate milk. Now, if you can remember this, kilo, hecta, deca, our unit, which is grams, meters, or liters, deci, centa, milli. Okay? And one thing to do when you're trying to remember, if you have 1 liter and you want to know how many milliliters that is, you look at the unit and you count how many places you have to move. That's how many zeros are going to come after this 1. So if liters is our unit and we want to go to milliliters, we jump 1, 2, 3 places. So that's 3 zeros. 1 liter is 1,000 milliliters. Now let's set this up. We start with our given, 400 milliliters. Our T-chart, that's over 1. Now, what units do we want to go down here? We want milliliters down here so that they will cancel out. So we have 1,000 milliliters and 1 liter on top. So 400 divided by 1,000, if you do that math on your calculator, what do you get? You get 0.4, right? So our answer is going to be 0.4, and we're looking for liters. Okay, our units cancel out, leaving us with the units for our answer. Let's do another one. Convert 10 meters to millimeters. Okay, so again, I'm going to put my little mnemonic device up here. King Hector died upon drinking chocolate milk. I know, it's silly, 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 but you know what? You'll find lots of things silly that I do that help you hopefully remember things. So, we have meters and millimeters. So meters is our unit, and we have to jump how many places? 1, 2, 3. So 1 meter, again, is going to equal 1,000 millimeters. Alright, so let's start our problem out. 10 meters, we want to convert to millimeters. So 10 over 1. We want these units to go down so they cancel out. So meters, 1 meter is going to go on the bottom. 1,000 millimeters on the top. Units cancel out. 10 times 1,000 is 10,000 millimeters in 1 meter. Okay. Let's try another one. Convert 73 grams to kilograms. Alright, here's King Hector died upon drinking chocolate milk. We want to go, so we need to know grams and kilograms. Here's the thing, if we're starting with grams, okay, if you write 1 gram is how many kilograms? You're going to bounce the other way, 1, 2, 3. So 1 gram is equal to 0.001 kilograms. Okay, if you go to the left, you have to move the decimal backwards. Okay, so let's set this up. 73 grams, that's our given. Put our T-chart. What units go down here? We want units to cancel out, so grams go down here. So 1 gram, and then 0.001 kilograms. So our answer in this case is going to be 0.073 kilograms. Okay, our grams canceled. We multiply that. This is the answer we get. Couple more practice problems. This one is interesting, and the reason we do this is I want you to remember the conversion factor here. Notice that we have milliliters to centimeters. So we can't just use our metrics conversion. There has to be some other conversion. And as it turns out, 1 milliliter is equal to 1 centimeter cubed. Okay, so that's something important for you to remember. I wouldn't be surprised if you see that question on a test or a quiz somewhere. What is that conversion? 1 milliliter equals 1 cubic centimeter. So now that we have our conversion, let's set this up. 175 milliliters. We want to convert it to centimeters squared. So we know these units are going to come down. So 1 milliliter on the bottom. What goes on top? 1 centimeter cubed. I guess I haven't mentioned the math of this, and bad on me. When you set these up like this, what we're doing is everything across the top is multiplying, everything across the bottom is dividing. So we would be doing the math 175 times 1, and then dividing by 1, dividing by 1. This one's kind of anticlimactic because it's all ones. We end up with 175 cubic centimeters as our answer. Okay, let's try one that's not metric. All right, we want to convert 14.90 pounds to grams. Notice down here I tell you that 1 pound is 453.92 grams. So this should be a piece of cake. We're going to set this up. 14.90 pounds, LB is the abbreviation for pounds. I'm going to put in my T-chart. This is over 1. Now, I'm going to use this conversion factor. What units go on the bottom? Pounds, yes. Pounds go on the bottom because we want them to cancel out. So the number that's with pounds is 1. So I have 1 pound on the bottom. That means that this number, 453.592 grams, goes on the top. Now, here's what I was talking about with that math. We're going to multiply 14.90 times 453.592. Okay, so if we plug that into our calculator, and then we divide by 1 and divide by 1. Okay, if you remember, dividing by 1 gives you the same thing. You don't have to go through those steps. Now, our answer comes out to be 6,758.5208. Now, here's something that we haven't really talked about because we've just been doing simple one-step conversions with the metric system, we have to think about sig figs in our answer. So how many significant figures are in this number? 1, 2, decimal presence, so all 4 of those, there's 4 significant figures. We do not count significant figures in conversion factors. Those are considered to be exact numbers, so those don't count. We only look usually at our given. So 4 sig figs means we can have 4 sig figs in our answer. 1, 2, 3, these 4. Since this is 5, we're going to round up, so our answer is going to be 67, 59, and our units, what are we looking for? Grams. So this would be the answer to that problem. What I want you to realize is anytime I give you a conversion factor, even if you're not familiar with it, you can carry out one of these conversion problems. So let's do one more. This is the last one, and this one's a little bit tricky. We need to go from seconds to hours. To do this, we need 2 conversion factors. I'm going to write them down here. Let's see, what do we know about seconds and minutes and seconds and hours? We know that 1 minute is equal to 60 seconds, and we know that 1 hour is equal to 60 minutes. So we have 2 conversion factors here. Okay? This is going to be a 2-step problem, and these aren't really that much more difficult than 1-step problems if you approach them correctly. We write down what's given, 4,588 seconds. We're going to draw our t-chart. Again, this is always over 1. Now, since we have 2 conversions, we're going to draw 2 parts to our conversion factor. Okay? Now, look at this. We have units of seconds here, so we know that down here we need seconds. So if we look at our conversion factors, there's only one equality statement, one conversion that has seconds in it. That's this one right here. Okay? So seconds is going to go on the bottom. 60 seconds is equal to 1 minute. Okay? Now we've used this conversion factor. What's going to go on here is dictated by what the units are up here. We have minutes up here, so we need minutes down here. Look at this. We have a conversion factor with minutes and hours in it. So up here, we want minutes, so it's going to be 60 minutes is equal to 1 hour. Now notice, seconds and seconds cancel out, minutes and minutes cancel out. That's going to leave our final answer in units of hours. So if we plug this into our calculator, and here's a good example of the math, we need to take 4,588 times 1 times 1. And then we need to divide it by 1, divide it by 60, and divide it by 60. So if I'm going to plug every step into my calculator, this is what I'm going to plug in. 4,588 times 1 times 1 divided by 1 divided by 60 divided by 60. That will give me the answers. Now, you can skip these 3 steps if you want, because we know that multiplying and dividing by 1 always equals 1. So let's see what we get as an answer. I get 1.27444 continuous eternity 4s. How many significant figures can I have in my answer? We're almost done. My given has 4 sig figs. That means my answer can have 4 sig figs. 1, 2, 3, 4. Since 4 is less than 5, we don't round up. So our final answer is going to be 1.274 hours. Alright, so that's a quick look at conversions. We will practice a ton of these in class. and hopefully you'll get way better at them, and it will be something that becomes easy for you. Good luck with this, and I will see you in class.